Hello everyone, welcome back to my AI/ML series. Myself Arnab Kundu. Today we are going to learn something very exciting in machine learning, ensemble learning. Okay, you know, when we take an important decision, we don't rely on just one people's opinion. We ask many people's and then make a final choice. Okay. That is exactly what ensemble learning does, right? It combines multiple machine learning models to make predictions that are more accurate and reliable. Okay, there are three main types of ensemble learning. One is bagging, also known as parallel learner. Number two is boosting, which is also known as sequential learner, and third one, which is stacking, also known as meta learner. So go to the computer screen. Step by step I will discuss ensemble learning elaborately. So let's dive in. Hello friends, welcome to my channel Technical ArCoAn. Myself Arnab Kundu. Today I will discuss ensemble learning. Okay, ensemble learning means combining two or more models to improve accuracy, because a single model may make mistakes, but when multiple models work together and their combined decision is usually much better, right? And for ensemble learning is concerned, the main three types are there. One is bagging, other is boosting, another one stacking. Okay, bagging means train multiple model in parallel, right? Boosting means train multiple model sequentially. Stacking means combine completely all models and a final model makes ultimate predictions, right? So now at first we should know what is ensemble learning. Ensemble learning combines multiple machine learning models to achieve better accuracy and robustness than any single model alone, because a single model can make mistakes, right? It works on the principle of wisdom of the crowd, where many weak learners together form a strong learner, right? Ensemble is combining multiple models to improve performance. Okay, helps reduce overfitting, variance and bias. Okay, so common types already told: bagging, boosting and stacking. Bagging is also known as parallel learner. Boosting is also known as sequential learner, and stacking is known as meta learner, right? Now we talk about the bagging and boosting. Bagging, also known as bootstrap aggregating, trains multiple models on random subsets of the data and averages or majority votes their results to reduce variance and overfitting, right? Example, random forest is a popular bagging method. I have already discussed in my earlier video on random forest classification model, right? So there is a given that the dataset means we take at first the dataset, and from there we create the random subset. Okay, and then we train multiple models in parallel on this subset. Okay, and then we combine all the result from the multiple model is concerned, and from there final prediction or ultimate prediction will come from there, right? And what is a boosting? A boosting builds models sequentially, where bagging is doing on parallelly. Boosting builds models sequentially, where each new model corrects the errors of the previous one It reduces bias and creates a strong learner from many weak learners, right? Example, AdaBoost, gradient boosting, like that. So multiple model, from there we find out the final strong model, right? Now talk about the stacking. Stacking combines predictions from multiple models, base learners, using a meta model, right? This leverages the strengths of different algorithms to improve performance, combines different types of models, not just one type. Base models like logistic regression, decision tree, support vector machine, like that, make predictions. A meta model, final estimator, learns from those predictions, okay, produces a powerful hybrid model, and its accuracy is more perfect, right? Here we combine logistic regression, decision tree and SVM, and the final prediction is made by another logistic regression model, okay? Now we talk about the key features and applications of Ensemble Learning. Combines multiple models, uses techniques like bagging, boosting and stacking. Higher accuracy, outperforms single models by reducing errors. Reduces overfitting, especially effective for complex datasets. Versatile, works with both classification and regression tasks. Robustness, handles noisy data and improves generalization, okay? And what are the applications? Finance, credit scoring, fraud detection, healthcare, disease prediction, medical image analysis, e-commerce, recommendation system, customer segmentation, cyber security, intrusion detection, malware classification, NLP, natural language processing, sentiment analysis and spam detection, okay? So go to my Google Colab workspace. I will step by step describe Ensemble Learning, okay? Now I am just my Google Colab workspace and code is already written to there, and we save the file and put the name Ensemble Learning.ipynb, okay? So at first we know for machine learning task is concerned, we import the libraries, means import the modules, pandas for the data manipulation and analysis, numpy need for the numerical computations, especially for array, and sklearn we know for machine learning tasks, and matplotlib and pyplot need for the visualization of data, okay? Then we load the dataset. So here we are using load underscore digits. Today I am using the digit dataset, the dataset which is built-in dataset in sklearn, and the number of sample is 1797 handwritten digit images. The feature per sample is 64, means each image is 8 cross 8 pixel, okay? And the class or label, or we can say the target value, is 10 because unique digits are there from 0 to 9. That's why the class or label is 10, okay? So this dataset I am just using here. Just write load underscore digits, and from there we find out the input features, means inputs and the outputs. So input is concerned, we already know, usually a 2D array, that's why using data frame. For outputs, it's the 1D array, that's why using the series. And then we just print the dataset shape, and the classes, means unique, the 10 classes are there from 0 to 9, okay? Then we use the train underscore test underscore split function for splitting the data. Training and testing is concerned, and here split in that way, 80% for training and 20% for testing. That's why the argument is test underscore size is equal to 0.2, and random underscore state equal to 42, means ensure the productivity of the result, okay? So x underscore train is the input feature for training, x underscore test unseen input features for testing, y underscore train the output value for the training, and y underscore test output values for the testing. In that way the split is going on 80-20 training and testing respectively. Then we use the first type, bagging, and here I am using this random forest, this particular model, random forest classifier, and here I am sending as an argument n underscore estimators 100. Why? Because here the random forest model is trained with 100 decision trees, okay, and their results are combined to make the final predictions, and the final prediction is made by majority voting. So that's why we train the model with the training data set, and then from there we find out the predicted value using some unseen input data for testing, and from there we find out the predicted output. Then we find out the accuracy, just sending as an argument the true output value and the predicted output value, just compare of the value is concerned. Then we use the second type, which is boosting, which is using here the AdaBoost. So AdaBoost or adaptive boosting is a boosting algorithm that trains multiple weak learners sequentially. The previous one at the parallelly means the bagging is going on parallelly, but boosting is going on sequentially, and it is simple, effective and great for demonstrating boosting. Okay, so same way we are using here the decision tree classifier model, and same way we train the model, then from there we find out the accuracy, means we predict and then we find out the accuracy of the boosting is concerned. And then we are using the stacking, where three different models we are using here, combining logistic, decision tree and support vector machine. So here selecting three base models for stacking: logistic regression, decision trees and support vector machines. So these models will first learn separately, and then their output will be combined, okay, by a final model for the predictions. Okay, so that's why there the simple names are given, short name LR for the logistic regression, DT for decision tree classification, SMV for the support vector classifier. Okay, and then what, now using logistic regression as a final estimator in stacking, it keeps the stacking pipeline simple and avoids overfitting. So also don't want the meta learner to be complex, so that's why we're using here the logistic regression, this particular model here. Okay, and after that same way we fit the model, means train the model, use the training data set, then predict the value and then find out the accuracy of this stacking. Okay, after that we compare the result, the accuracy of this bagging, accuracy of the boosting and accuracy of the stacking, and if we find out the result of the accuracy, and then we use the evaluation process, means we evaluate the model. So that's why we are using here classification report, okay, of the stacking. We find out the classification report of the stacking, means we evaluate the model, and then we visualize through the 2D graph. Here I am using the bar chart. Okay, so plotting a bar chart to compare the accuracies of bagging, boosting and the stacking, and this helps quickly to see which ensemble technique performs better on our dataset. Okay, so our dataset is a digit dataset, which is actually a handwritten digit images. Okay, so from there these models are there, the bagging, boosting and the stacking. Okay, and from there we just give the title Ensemble Learning, bagging versus boosting versus stacking, and y axis given accuracy, and then we find out the confusion matrix for stacking. Okay, and after that it will generate the result. So we just execute this code, so just press this button, so it will take some time to generate the result, and also the visualize the result in a 2D graph in a bar chart is concerned. Okay, so the result is already generated. So just first given the data set save, already told the number of sample is 1797 and featured part samples are 64. Okay, and classes, unique classes are 10, 0 to 9. These all are the digits, and then find out the accuracy for bagging near about 0.9722, means 97%. For accuracy boosting 0.8277, means near about 83%. And for accuracy for stacking, where we combine these three different model, logistic, decision tree and support vector machine, and the accuracy is 0.9805, near about 98%. Right, after that we find out the classification report of the stacking, so precision, recall, F1 score and support. Okay, and then this is the 2D graph, where for the bagging this accuracy is given near about, already told, near about 0.975. Boosting is very low, near about 82. Low accuracy is boosting, but highest accuracy or near about perfect accuracy for stacking for these three models concerned, which combine these three model, near about 98%. Right, so near about the 98% is there, and this is a 97.2. Okay, and after that it will generate the confusion matrix result. So these are the true class 0, true class 1, true class 2, in that way true class 9, and same way this is the predicted class 0, predicted class 1, in that way predicted class 9. So all the diagonals values are more, that means the model works perfectly. This cell contain 33 means 33 samples from the true class 0 are correctly predicted as 0, and same way the last diagonal part 38 means 38 samples from the true class 9 are correctly predicted as class 9, and some part is 1 is given, some misclassification are there but very low, but overall when we combine the more than one models, then it ultimate predictions is more accurate and better. This is the most important part of ensemble learning in machine learning is concerned. Generally improves accuracy and robustness. I hope you have understood today's video. Today's video is on ensemble learning in machine learning. If you have some doubts for today's video is concerned, just write in the comment section. I will try to solve this problem. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical ArCoAn for more videos, because more AI/ML videos will come very soon. So today up to this. Thank you and bye bye.